In this example, we want to find the sum of an arithmetic sequence. The sum is 11 plus 15 plus 19 plus and so on until 67. Since we know that this is the sum of an arithmetic sequence, we will use the formula for the sum of the first n terms of the arithmetic sequence. The formula is the sum of a sub 1 plus a sub 2 plus and so on until a sub n is a sub 1 plus a sub n over 2 times n, which means that we have to add the first term in the sum with the last term in the sum, divided by 2 and multiply by n, which is the number of terms we are adding. So our sum, which is 11 plus 15 plus 19 plus and so on until 67, is going to be the first term, which is 11, plus the last term, which is 67, over 2 times the number of terms that we are adding, which is the value of n. The problem is that we don't know what that value is. However, we know that the sequence is arithmetic, and we know that the first term, a sub 1, is equal 11, and the last term, which will be 67, is a sub n. We also know that a sub n for an arithmetic sequence is a sub 1 plus n minus 1 times d. Since we know that this is an arithmetic sequence, we are told that from the beginning we can figure out the value of d, because in arithmetic sequence the common difference d is the difference between any two consecutive terms. So for example, we take term 2 and subtract term 1 and we'll get the value 4. So that common difference is 4. And now if we use the general formula for the nth term of an arithmetic sequence and noting that a sub n is 67, we'll get the equation 67 equals 11, this is a sub 1, plus n minus 1 times the value of d, which is 4. Solving this equation will give me value of n, which is the value of number of terms that are added in this sum. Now 11 minus 4 is 7, we'll subtract from both sides, we'll have 60 is equal 4n, and therefore n is equal 60 over 4, which is 15. So we know that we are adding 15 terms. So we take the number 15 and plug in into the formula. So that sum that we already written, or that fraction, is going to be multiplied by 15. And therefore we'll have 78 over 2 times 15, which is 39 times 15, and that number is 585. So 585 is the sum given at the beginning of 11 plus 15 plus 19 plus and so on until 67.